Hello everyone, welcome back. This will be about determining enthalpy changes of combustion. So in the previous lessons we have learned how to solve enthalpy changes of neutralization through experiment using graph, but for combustion it's a little bit easier. We will not be dealing with graph, so it's quite straightforward once you understand the principle of neutralization. Okay, so let's look at the setup. Setup, do you have to memorize? Yes, you have to memorize the setup. So let's get through it. Usually when we do enthalpy change of combustion, it's usually of a fuel. So we either use ethanol, a type of alcohol, or oil. Now this is the apparatus, so something different or something that we have not seen, it's this one, drought screen. All right. The rest you have mainly seen it before, and the spirit lamp actually, you have not seen this before. So let's understand this setup. So ethanol, the liquid or the fuel we want to burn, will be always in the spirit lamp. So we just light it up if we want to measure the temperature. Excuse me. And then, now for neutralization, we used polystyrene cup. Now since here involves burning, we cannot use it, so obviously it will burn. In this experiment for combustion, we use a copper can, right? And it's usually containing known mass of water. So, and we have a stirrer obviously to ensure uniform heating. Thermometer again to measure the heat change or the temperature change. We have the lid. Now the drought screen again, it prevents the heat escaping. Heat loss, so heating other things. So it's used for reducing heat loss to the surrounding. Drought screen. Now, why do we use copper can? Now this copper can is actually quite thin. So what happens is that when we light up the spirit lamp, the heat will travel through the can into the water. The water will start heating up. So once it starts heat up, the temperature will start to change. So therefore, that's how we will be able to measure the temperature. But is it like neutralization? Do we have to time it every 30 seconds? No, we just want to measure the highest. So we light it up for around, let's say, 10 minutes. And the maximum is what we need. So the maximum. So the minimum will be obviously before the experiment starts, and the maximum will be throughout the experiment, and we'll find it out. So what are the experimental steps? So it's quite simple. First, we measure the mass of the spirit lamp containing the ethanol. We measure this mass. Okay? Why? Because after the experiment, we will have to measure it again. So we will find the change in the mass. The change of the mass will tell us how much ethanol was used. We will not be using all of them. And record the mass and the initial temperature of the water in the calorimeter. So this thing is still called a calorimeter. Ignite the spirit lamp and record the maximum temperature. So remember again, maximum. And the mass of the spirit lamp after the experiment. So roughly you will always given this data. Mass of the water, spirit lamp before and after, initial and final temperature. So, first things first, we have to find the energy. So energy, again, we have to use E equals mc delta T. So we have E equal mc delta T. So what's the mass over here? So this one mass we're going to be used is not the mass of the ethanol here. Okay, you have to be careful. We're not going to be calculating mass of ethanol. So this one is actually mass of water. Now you'll be asked, why water? Because we actually heated up the water. That's where the temperature change happened. So therefore, the mass of will be mass of water times specific heat capacity of water times temperature change. So this one. So 37.6 minus 18.3. So after you find the energy, all right, so again, the textbook uses 3 sig fig. I do not prefer you to use that. It should be around 20.19 something. Whoa, what happened? Oh, there you go. Okay, so after we find the energy, we have to find number of moles. Now, number of moles, you have to be careful. We do not have molarity, we do not have volume. So unlike neutralization, we will have to depend on the mass. So how do we find mass of ethanol? So we have to use the mass of spirit lamp. So before, how much ethanol was containing with the spirit lamp, and afterwards. So the change, we will know that how much ethanol was used. So we have mass. So we have mass of ethanol after doing subtraction. How do we know the mole? So we're finding mole. So we'll need the molar mass. So mass over molar mass, you get number of mole of ethanol right here. So the mass is the difference, and the number of moles. The molar mass. You'll find the number of moles. So again, we have to find the heat released. As I said if you've watched the classwork example I've done of enthalpy change of precipitation, I've emphasized in that part as well. First, you have to write heat released. You don't have to write the whole this thing. So just do heat energy divided by mole. You will get this. You will not see any sign in the front. And then next statement, we will write enthalpy change of combustion will equal to negative sign. So you will see negative sign in the textbook right here. Okay, so basically that's how you do it, and not difficult at all. So if you want to practice, please do this before my lesson on Monday. Now Monday I will still talk about actually this chapter. I want to finish off 3B before I start revising other chapters, otherwise we'll be too slow. So I think for the next 2 to 3 weeks we will try to rush up the syllabus as soon as possible, okay? And then we'll start revising the previous chapters. So please do this before my class. So again, really easy. All the information is given, and you have to find the enthalpy change of combustion. And then we'll be done with unit 34. Okay, so that's it for this video.